Hi everyone, this video is on exercise 11a question 7. So we have f of x, which is 1 over x, 1 over 8x to the power of 3 over 2 minus 4 over x. And in part A, we want to solve the equation f of x is equal to 0. Okay, so we have 1 over 8x to the power of 3 over 2 minus 4 over x is equal to 0. So first of all, we can multiply both sides by x to get rid of this x, which is on the denominator of the second term. So if we multiply by x, we are going to get 1 over 8 x to the power of 5 over 2 minus 4 is equal to 0. Now let's rearrange this. So we have we can now multiply both sides by 8, and that gives us x to the power of 5 over 2 is equal to 32. Right. Now at this point, we can just simply because x is equal to 32 to the power of 2 over 5, right? That just sort of the reciprocal of this fraction, because that's the opposite. So now we can just use calculator to find this value, and this is simply equal to 4. Now in part B, we want to find, we want to integrate f of x. So f of x is 1 over 8x to the power of 3 over 2 minus 4 over x dx. Okay, so let's rewrite this integral in the form x to the... Oh, actually, this is the case that we cannot do that because the first term is already written in the form of x to the power of n. But the second term, which is 4 over x and x on the denominator, you know, if you write this as x to the power of 4x to the power of minus 1, then there is a big problem because we cannot integrate that with the method that we have learned in Pure 1. And this is actually a standard result that any constant over x integrates to simply that constant times ln x. So in this case, the first term is very clear. So for the first term, we just add 1 to the power, which is 5 over 2, and then we divide 1 over 8 by 5 over 2. So that gives us the first term. And so we don't need this. So we have x to the power of 5 over 2. And then for the second term, we get 4 ln of mod x plus c. That's just because, again, any constant then over x when x is on the denominator, that integrates to that constant on the numerator times the ln of that particular thing that we have on the denominator. So in this case, we can simplify this. So for this term, we get 2 over 40, or just 1 over 20. 1 over 20 of x to the power of 5 over 2 minus 4 ln mod x plus c. And that's simply the integral. And finally, for part C, we want to evaluate this integral between 1 and minus 4. And we want to give the answer in the form p plus q ln r. So this is very important because in the exam, if you don't give your answer in this form, even if your answer is equivalent to that, you'll probably lose a mark for that. So in this case, we want to evaluate the same thing, but this time is a definite integral. So we can just use what we found in the previous part. So that's 1 over 20 x to the power of 5 over 2 minus 4 ln x, and then we have 4 and 1 as the limits. Okay, so we first substitute 4, and we'll get 1 over 20 times 4 to the power of 5 over 2 minus 4 ln 4, minus then 1 substituted, which is going to give us 1 over 20 minus 4 ln 1, which is 0. But I just wrote that for now. Okay, so 4 to the power of 5 over 2 is equal to 32, and then 32 times 1 over 20 is just 32 over 20. Now for this term, which is minus 4 ln 4, we can keep that in this form for now. And here, which is, because here minus 4 ln 1 is just 0, and then we'll have this 1 over 20, so we get minus 1 over 20, and then 32 over 20 minus 1 over 20 is 31 over 20, minus 4 ln 4, and that's it, because the question says give in the form P plus Q ln R, which is exactly the same form. So this is P, this is Q, and this is R.